we're going to look at adding trig functions. So the goal today is going to be able to take two trig functions and they're going to have the same horizontal transformation, so the same stretch compression. It's not going to be a left-right, it's going to be a stretch compression. So what that means is that on each one of these questions you're going to be working with, you'll have some function in terms of either sine or cosine, and then another function in terms of sine or cosine. And they should, I believe, I'm not sure, but for the questions I've seen, these match. So they're both in terms of sine or both in terms of cosine. We can look at some more challenging ones later where maybe they're one's cosine and one's sine, but for now, let's just stick with the same. The other thing that will always be the same, and they say really clearly in the syllabus, is that this horizontal stretch compression, this B value, is always going to be the same. So that's important when we're doing these questions. So we're going to look at an example where we use sort of what I would guess the reasoning you guys came to after the activity that we did the other day in class, where we added components together and we were looking at just transforming between the sine function and cis and the e to the I, all of those different notations. So we're going to look at what I would consider this like method one, and we're going to call this sort of an intuitive approach to what we're doing. But I think we need to be really clear in this situation that everything we're going to do here in method one is bad grammar, and you'll see why. So we have this function right here, 3 sine 20t, and then we have another function right here, 4 sine 20t plus pi over 4. And we want to add them together, okay? So here we've got the 3 sine t and the 4 sine t. And we want to know if at some x, right, if I take, for instance, x equals 0 in each situation, and I add these two functions together, what is the new function? So if I add the y values for any corresponding x value, what would be the new y value? And so it's not as easy as you'd think it would be, right? It's not like you can just add pi over 4 and make it work. So what we're going to have to do here is we're going to have to look at some parts. So what we're going to do is we're going to use this idea of complex numbers and these cis notations to help us figure out what exactly is happening and how we can blend these two things together. So we know that if 3 sine 20t is part of the function, then we know that that can be represented as a portion of this function as we cycle around the circle at 20 being our frequency, our hertz, basically, in this situation. And then if we have another one, here's this guy, he's the purple, right? So they're both oscillating at the same speed. That's important in being able to do these. So we're going to take each one of these, now we're going to convert them into rectangular, which is what I would suppose you guys probably did in the last homework assignment, where you said, well, if I turn these both into rectangular, then I can take each one of these pieces at the start and say at the start, you know, what are their y values and what are their x values, right? Because we're talking about sine here, for this function, we're really just talking about these y values. So at the start, if I were to combine these two functions together, what would their new values be? What would this new function's output be? So our new function is going to be 3 plus 4 root 2 over 2, which turns out to be 5.83. So when I add this term and this term, right, after I distribute, what I end up getting is 5.83. Now if I take this term and this term, this ends up being the imaginary component. And it ends up being, what is it, 2.83i. So we've blended these together and saying when they start, and t equals 0 basically, where are these going to be? But we have this 20t here, and it's not like we're multiplying it in per se, because it's really a component of a function that's nested inside of these things. And so we don't write things like this. This is that bad grammar. Like, how do I tell people that this is really a cosine or a sine function or a cis function, and this is 20t that applies to it as you're taking that sign, right? Like this doesn't convey any of that information. So we're just kind of using this to give us our initial idea here. So when we take these pieces of information right here, this is going to give us our starting function. So we have 5.83 being the real component and 2.83i being the imaginary component. And when I stick that in my calculator, I just did find the argument, find the modulus. This right here ends up being 0.452 as theta, and the modulus of this guy is 6.48. So it's not what you would expect here. It's not like this is 7. It's not like this is pi over 4. It's something different. So we're going to go to our graphing calculator here, and we're going to see, I went ahead and we're going to drop those right here, and we're going to say this is the function, this is what we know it should look like when we graph it, right? It should look like this. I just directly copied it over. Well, does our function produce that same thing? Yes. Yes, it does. So that means that we definitely feel confident that this is the correct way of doing this question. However, right, bad grammar. So we take this information, we've combined it together, and it wants to know, since we were all focusing all this information about sine and cosine, right, all this about cis, our initial question was about sine, so we need to make sure to put it back in terms of sine. Again, really, really bad grammar. So we're going to do the good grammar way, which is basically the same thing, but this is the more accepted notation that you would see in like an engineering class. So we have our two functions, just like we did before, and instead of breaking them down into cis or rectangular at this point, we're going to put them into Euler. So this guy and that guy go together, and this guy and this guy go together. And what I had you guys do in the last homework was I had you, on faith, because you trust me, break this up into these two components, right? This whole thing right here is equal to this, right? So now we're going to do something that allows us to maintain the integrity of the algebra, which is we're going to factor this e to the I 20t out of each component. So we're going to pull that out as a factor right there. Now we simply have 3 plus 4ei pi. And all I did is I took this expression right here, 4ei e to the I pi over 4, and I just stuck it in my calculator, and it produced this response right here. And then if you look at that, hey, look, there's that same number that we got right there, the 5.83. So e to the I 20t, 5.83 plus 2.82i. And now this right here can be expressed still as, we just leave this here, we're carrying it through algebraically, 6.48 cis 4.452. Okay. So this is the clean, nice algebra, right? So now this guy right here is going to become e to the I 20t, and we're going to put this in terms of that Euler form, 6.48 e to the I 0.452. And now, being nice and tidy, we're going to say the magnitude on this is that, right? Magnitude on that's that. Put them together by multiplication. 6.48 e to the I 20t plus I 0.452. And then technically we should probably pull that I out front. So making it nice and clean down here at the end. E to the I 20t plus 0.452. So this is the good grammar version, right? This is what IB or any college professor that we're looking for at something like this is what they would be looking for. This is the way a person who's proficient in mathematics would write something like this. This is intuitive and sort of how we built our whole question around this idea, but this is the good grammar way. So we're going to be working on these as we meet up tomorrow and just kind of looking at how can we apply these on some of those tougher questions, and I'll just be spending class with you going over some of these questions together. So looking forward to seeing you soon. Bye.